This is the second video in an introduction to trigonometry. In the first video we looked at the definition for sine being opposite over hypotenuse, cos being adjacent over hypotenuse, and tan being opposite over adjacent. Now in this example we're not given either angle A or angle B, but we're given two sides. Now if you're going to find the value of one of these angles, you have to decide first of all which angle you're going to use. If I'm going to use angle A, the adjacent side is 4 and the hypotenuse is 8. If I'm going to use adjacent and a hypotenuse, that means I'm going to use the cosine. So I set it up like before. Cosine of A equals 4 over 8. But this time I don't have an angle to operate on. So I can't use the cos button on the calculator. I have to use the cos inverse button. Now you see I changed this to a decimal. You don't have to do that first if you don't want to, but you've got to use second function to get the cos inverse. And if you do that on the 0.5, that will give you angle A. Then of course angle B, normally I subtract two angles from 180, but in the case of a right angle triangle, I already have 90 here, so I know the other two add up to 90. So to get angle B, I just subtract the 60 from 90 and I get angle 30. Now I'll just look at one more example where we're given two sides and no acute angle. Once again, I have to decide which angle I'm going to use. If I decide to use angle A, I'm going to use the tan of A, which is the opposite over the adjacent. Now this time I didn't bother working out the decimal equivalent of 5/12. On my calculator I just used second function, hit the tan inverse button, open a bracket, enter 5 divided by 12 and close the bracket. Depends on the type of calculator you use as to how you're going to do this. But that immediately gives me angle A, which is 22.6 degrees. Again, because A and C add up to 90 degrees, I can get angle C by subtracting 22.6 from 90. If on the other hand I had decided to try to find angle C first, the 12 would have been opposite and the 5 adjacent. So I'd be using the tan of C is 12 over 5, opposite over adjacent. Very similar to what I did over here. Angle C then is the tan inverse, again second function of the 12 divided by 5. That would give me the 67.4, and then to get angle A I would subtract the 67.4 from 90 to get angle A. And that's the way you work at right angle triangles where you are given two sides. We could then use another trig ratio to find the length of AC, or you could use the Pythagorean theorem to find that length.